we're going to fairly quickly consider the rational function y. Well, you can read it here. We have a quadratic here, a quadratic here, and a quadratic here. The zeros of the numerator occur when x squared minus 5x plus 6 equals 0. And that occurs, I'm not going to go through the solution. This is factorable, or you can use a quadratic formula, or you can complete the square. But this is going to be 0 when x equals 2. Also when x equals 3. And then the numerator also contains x squared minus 16. That equals 0 when x equals 4 or negative 4. Again, not going to go through the details of that solution. You should be easily able to verify these solutions and find these solutions yourself. Okay, zeros of the denominator occur when x squared plus 7x plus 6 equals 0. And that occurs when x equals negative 1 or x equals negative 6. So we can put that behavior onto the graph, and we will in a minute. Let's just look at the end behavior. For large x, implies that the behavior of this function is going to be close to x to the 4th over x squared, because we can see easily if we multiply these two polynomials, the leading term, the highest degree, is going to be the x to the 4th in the numerator, and in the denominator the highest degree is x squared. So that's going to be like x squared, and as x approaches plus infinity, y approaches infinity, and as x approaches negative infinity, y also approaches infinity. Because, of course, when you square a large number, doesn't matter whether it's positive or not negative, you're going to get a positive. And y is going to approach infinity rapidly. It's not going to approach along a slant asymptote, for example. A slant asymptote can occur, as we've seen, when your numerator has when the degree of the numerator is 1 greater than that of the denominator. Here the degree of the numerator is 4, the degree of the denominator is 2, so the difference is 2. And if you want to go into a little more detail on this, as x gets large in this direction or this direction, the graph actually approaches the graph of y equals x squared. Now in between here, it goes through all these asymptotes and zeros and everything. Okay, so let's summarize that on the graph. We have zeros at x equals 2. Put 1 here, so 2 would be here, and 3, and also at 4, and also all the way over here at negative 4. Okay, so there are the zeros. We have zeros of the denominator, which imply asymptotes. Zeros of the denominator imply vertical asymptotes. So at x equals 4 and at x equals negative 1 and negative 6, here's x equals negative 1, we're going to have a vertical asymptote here. And let's see, this is negative 4, so negative 6 is going to be a little further over here. X equals negative 6, we have another vertical asymptote. Let's make use of all the torch space we've got. Hope that stays there. Also, the behavior here is it goes up, and the behavior on the right is it goes up. So the broad view is like a parabola that comes down, squiggles around here and goes through the zeros, and it is asymptotic to the asymptotes. We also know that the y-intercept, which is going to be obtained by letting x equal 0, it's going to be 6 times negative 16, which is negative 96. You divide that by 6, you get negative 16. So the y-intercept is at negative 16. Okay? So what happens? From the right, we come down here. We're going to go through this 0, back up through this one, down through this one, and then we're going to approach the asymptote. We're going to have to go through the y-intercept. Let's say that's here. And we're going to go down this way. Now, as we cross x equals negative 1, as you can check, the sign of the function changes. So we come down from above toward this asymptote, and we come down below here. Meaning that when we come down here, there's no 0 over here for us to go through, so we got to come down here and then back up along this asymptote. So the graph is going to do this. Okay, from here, it's going to come down to some level. I'm not sure how far it comes down, and that's something you can learn if you take a calculus course. You can learn to find that point. Then from this side, it's got to come down through this 0, back up through this 0, down through this 0, maybe changing direction a little bit here before approaching this asymptote. And then on the other side of the asymptote, it's got to come down from up here, come through here, and down through here. So there's a rough graph of this function showing its main behaviors.